Welcome to chemistry classes. In this video we are going to discuss about chemical properties of elements. Mainly here we are going to learn chemical properties of metals. Chemical properties of metals. Okay. So here first I am giving some pictures here. You observe this. Okay. Here you have burning of magnesium. Okay, magnesium after burns, you can see what happened here. Okay, also here iron after burning, iron you cannot burn at a normal temperature. Okay, also aluminum cannot burn at a normal temperature. Soft metals like magnesium, sodium, potassium you can burn at a normal temperature. Okay, so after observing this, you can see here metals after burns it will change its color. Metals after burning it will change its color. Clear? Also you can see here all metals not showing same appearance after burning. You know, magnesium after burns it produce white ash, white powder. Okay, but sometime copper after burns it will produce black. Copper after burning it will turns to black. Okay, magnesium after burning it will turns to white ash. So there are some difference. Okay, so we have to learn more details about this. So here first chemical properties of metals, reaction with oxygen. Metals react with oxygen. Reaction with the oxygen mean, you know, burning. Burning means something reacting with the oxygen. Okay. So look here, we have to discuss here first chemical properties of metals. Metals reacting with oxygen. Okay, here you have to understand generally metals after reacting with oxygen it form metal oxide. Metals after burning it produce metal oxide. Clear? Metals after reacting with oxygen form metal oxide. Example for this, copper reacted with oxygen, copper oxide. Aluminum reacted with oxygen, aluminum oxide. Okay, so metals after reacted with oxygen form metal oxide. Okay, these are the balanced equation. Okay, balanced equation. Also here you can see balanced equation. How to balance a chemical equation. I already uploaded a video how to balance a chemical equation. So you can watch that video how to balance a chemical equation. Okay, there are many equations, different steps to balance chemical equation. You can watch it. Okay, now I am not going to how to balance this equation. Here you just understand here reaction with oxygen. Metals react with oxygen, it form metal oxide. Here copper reacted with oxygen, copper oxide. Aluminum reacted with oxygen, aluminum oxide. Here generally metal oxides are basic. Generally metal oxides are base. Okay, base or alkali. Base or alkali. There are some difference in base and alkali we will discuss. Now see here, generally metal oxides are basic. Okay, here I told you not all metal oxides are basic generally. Okay, there is some exception case. Some metal oxides are amphoteric. Okay, metal oxides are basic but some metal oxides are amphoteric. Amphoteric, you know, substance, acidic substance, basic substance, and another one amphoteric substance. So you can classify substance acidic, basic and amphoteric. Okay, acidic substance mean substance their pH less than 7, pH less than 7. Basic substance mean substance their pH more than 7. So that is acidic substance and basic substance. Amphoteric substance mean some substance that showing both acidic and basic properties. Such type of substances called amphoteric substance. Amphoteric substance means substance it showing both acidic properties also basic properties. Such type of substances called amphoteric substance. So here aluminum oxide lead oxide, zinc oxide. Aluminium oxide, lead oxide, zinc oxide, these are metal oxide. This type of, not only this type of metal oxide, there are some other examples. Here you just remember aluminium oxide, lead oxide, zinc oxide, these are amphoteric oxide. Amphoteric mean they are showing both acidic and basic properties. Look here, I told you here aluminium oxide, it is acidic, it is amphoteric. Okay, amphoteric mean, also you remember I told you three different type of substance: acidic substance, basic substance, amphoteric substance. Okay, so also you remember here acidic substance, there is no reaction. Two acidic substance do not react each other. Okay, similarly here basic substance, two basic substance together, also no reaction. Acidic substance, no reaction. Basic substance, also no reaction. Okay, but amphoteric substance can react with the acidic, because amphoteric mean it's showing both acidic and basic properties. So it can react with the acid. So there will be chemical reaction. Also amphoteric substance also it react with the alkali, there will be chemical reaction. So amphoteric substance it react with acid, amphoteric substance also react with the alkali. Clear? Now see here, aluminium oxide, it is amphoteric, so it react with the hydrochloric acid, it form aluminium chloride and water. Aluminium oxide again, it react with sodium hydroxide. This is hydrochloric acid, it is acid. It is sodium hydroxide, it is alkali. Okay, so here it is amphoteric, that's why it reacting with the acid, also it reacting with the alkali. Clear? Aluminium oxide reacted with hydrochloric acid, aluminium chloride and water. Aluminium oxide reacted with the sodium hydroxide, it formed sodium aluminate, NaAlO2. Here NaAlO2 means sodium aluminate plus water. Okay, so amphoteric substance, it will react with the acid and base. So you have one question, you are given one metal oxide, how can you check it is amphoteric or not amphoteric? The given substance reacting with the acid, also it reacting with the alkali, so it will be amphoteric. Okay, another question, you are given one metal oxide, suggest two reagents to show that given substance is amphoteric. You have to suggest two reagents to show that given substance is amphoteric. Okay, so which are two reagents? You have to say one acid, you have to say one alkali, so you have to say any acid, hydrochloric acid. Okay, any alkali, sodium hydroxide. Okay, so these are the two reagents. Clear? Okay, next one we have to discuss here, base and alkali. I told you before there is some difference between base and alkali. Okay, look here, simply you can understand here difference between base and alkali. All metal oxides are base. Okay, all metal oxides are base. For example, iron oxide, copper oxide, etc. Except amphoteric. I told you amphoteric, aluminium oxide, zinc oxide, lead oxide, they are amphoteric, not base. Okay, but except amphoteric, all metal oxides are base. Okay, here Fe2O3, copper oxide, sodium oxide, potassium oxide, these are all of them metal oxide, all these are base. But some metal oxide will dissolve in water. All metal oxide do not dissolve in water. Okay, only some metal oxide dissolve in water. Example, sodium oxide, potassium oxide. Okay, such type of metal oxide, they dissolving in water. Such metal oxides are called alkali. All metal oxides except amphoteric metal oxides are base, but metal oxide, those dissolve in water, called alkali. Okay, so example for alkali: sodium oxide, potassium oxide. These are example for alkali. Okay, so I told you this is alkali, it will dissolve in the water. Sodium oxide dissolve in the water, form sodium hydroxide. Potassium oxide dissolve in the water, form potassium hydroxide. Okay, so alkaline metal oxide dissolve in the water and they produce alkali. Sodium hydroxide, potassium hydroxide, they are alkali. Alkali means it turns blue, red litmus paper to blue. Okay, that is alkali, and their pH will be more than 7. Look here, another thing you have to understand here, sodium, potassium, this type of metals, especially in periodic table group 1 metals, they react rapidly with oxygen. Even these metals like sodium and potassium, you cannot keep in normal air. You cannot keep this sodium and potassium in an open container. It will react rapidly with the oxygen present in the air. No need to any heat or anything. Without heating, it will react with air, or it will reacting with the air mean reacting with the oxygen. Clear? That's why this type of metals, sodium and potassium, these metals are keeping in kerosene. Okay, we will keep these metals in kerosene because we cannot keep them in open air. Clear? Also, we cannot keep sodium and potassium in normal water. We cannot keep this in water because it will react with water. Also, sodium and potassium reacting with water, also it will react with the air. That's why this sodium and potassium keeping in kerosene. So these are highly reactive metals. Okay, magnesium reacting with the oxygen, but you can keep magnesium in open air. It do not react rapidly, but it will react after heating. Magnesium react with the oxygen after heating, after burn. So you need to burn magnesium, then it will react with oxygen. Okay, so compared to this, magnesium is less reactive. Sodium and potassium are highly reactive, magnesium comparatively less reactive. Also here Fe, iron do not react. You cannot burn iron after heating in air. You need to apply very high temperature, not normal flame. You have to heat electric heater, or you have to use higher temperature to melt or to react iron with oxygen. So here iron is less reactive. So look here, sodium and potassium rapidly react with oxygen. Also you cannot keep in air. Okay, magnesium, it will react after burn in air. Okay, iron do not react with the oxygen after burning in air. So according to this information, you can arrange these metals according to their reactivity. Okay, look here, potassium and sodium, they are highly reactive, then magnesium, then iron. Okay, so this is the order of reactivity according to this information. Clear? Okay, next one we have to discuss here, metals react with water, reactions with water. Okay, so also here some pictures are given. Observe this picture carefully. Okay, then you have to see here what are the things happening when metals reacted with the water. Also check all metals are reacting with the water, etc. Okay, after this, look here, you can check here metal reacted with water. Okay, all metals not react with water. I told you group 1 metals, group 1 elements in periodic table, group 1 and group 2, they are soft metals, alkali metals and alkaline earth metal. Group 1 elements are called alkali metals. Group 2 elements are called alkaline earth metals. So these metals are highly reactive. Even it react with cold water. Okay, so here sodium, potassium, calcium, this type of metals react with cold water. Okay, but Magnesium cannot react with cold water. Magnesium react with hot water. Magnesium reacting with hot water. Clear? You know, highly reactive metals like sodium, potassium, it react with cold water. After reacting this, it produce hydrogen gas. You can see bubbles are formed. These bubbles are hydrogen gas. Okay. Also, metals reacted with water, such as like you know, highly reactive metal sodium, potassium, it react with water, it produce heat. Also, it produce fire. Okay. Also, this highly reactive metals, it will float on the surface of water. Sodium, potassium, it will float on the surface of water. It produce fire, it produce heat. Okay, it produce hydrogen gas. These are the example. These are the observations. These are the observation metal reacted with water. Clear? Also, you have to remember here. Metals reacted with water, it form metal oxide and hydrogen. Metal reacted with water, it form metal oxide and hydrogen. Remember this. Before I told you metal reacted with oxygen, metal oxide. You have to remember that these things. Clear? Metal reacted with oxygen, metal oxide. Similarly, metal reacted with water, metal oxide and hydrogen. Okay, same metal oxide again reacting with the same water, it form metal hydroxide. Okay, so metal reacted with the water, metal oxide and hydrogen. Metal oxide, same metal oxide again dissolve in the water, form metal hydroxide. Clear? So metal reacted with the water, which gas formed? Hydrogen gas is formed. Okay. Okay, next one. Look here, I told you here magnesium do not react with cold water, it will react with hot water. Magnesium react with hot water. Magnesium reacted with hot water, it formed magnesium hydroxide. Magnesium hydroxide and hydrogen gas. Magnesium reacted with water, magnesium hydroxide and hydrogen gas. Okay. After that, you have to understand, I told you calcium it react with cold water and form calcium hydroxide and hydrogen. Magnesium react with hot water, calcium react with cold water, because calcium is more reactive than magnesium. Clear? So according to these things, you can say here sodium and potassium are highly reactive. It react violently, it produce violent, it produce some sound. Also, it produce fire. Okay, little bit explosive reaction, sodium and potassium with water, violent reaction. But here calcium not that much violent reaction. Okay, but it react with cold water and form calcium hydroxide. Magnesium is comparatively less reactive. It do not react with cold water, it will react with hot water. Okay, when you put calcium in water, you can see calcium reacting with water. Also, this calcium will move upward in water. What is the reason? When you put calcium in water, it moving upward. Reason for that, when calcium reacting with water, it produce hydrogen gas. Hydrogen is gas, it coming upward. So this hydrogen gas bubbles push calcium to upward. That's why calcium moving upward in water. Clear? Look here, you are given three different metals, sodium, magnesium, iron. Okay, and equal amount of water in three different beaker. You can arrange these metals according to this observation. You can arrange these metals according to reactivity from this observation. Look here, three beaker with equal amount of water. You added equal amount of sodium, magnesium and iron into each beaker. Okay, in first beaker there is sodium and water, and you can see many bubbles are formed. Okay, also you can see there is fire. Okay, and in case of magnesium, we know there is no reaction with the cold water. We can choose here calcium. Okay, magnesium do not react with cold water. Okay, so I choose here calcium. In calcium you can see few bubbles. Here many bubbles are formed, comparatively here few bubbles, and here iron there is no bubbles. From this observation you can say iron do not reacting with cold water. Calcium and sodium, in sodium there is fire and many bubbles, so it is highly reactive. Sodium is highly reactive, then calcium, then iron. So this is the arrangement of metals according to reactivity from this. Okay, next one we have to discuss here, metals react with acid. Metal react with acid. Okay, so here you have to remember here, metal reacted with acid, it forms salt and hydrogen. So we discuss metal plus oxygen. Metal reacted with oxygen or air, it formed metal oxide, metal oxide. Metal reacted with water, metal oxide and hydrogen. Same metal oxide again dissolved in the water, form metal hydroxide. Clear? Third one here, metal reacting with acid form metal plus acid, salt and hydrogen gas. Clear? Also here hydrogen gas is formed. So remember here, mainly we have to understand three different type of acid: HCl, HNO3, H2SO4. These are the major acid. Mineral acid, HCl, HNO3, H2SO4. HCl mean hydrochloric acid, HNO3 mean nitric acid. This is hydrochloric acid, nitric acid. H2SO4 means sulfuric acid. Okay, hydrochloric acid, nitric acid, sulfuric acid. All this acid reacted with the metal form salt. Okay, so here hydrochloric acid form chloride. Name of salt formed from hydrochloric acid, we will say chloride. Nitric acid, we will say nitrate. Sulfuric acid, we will say sulfate. Okay, so example for this, magnesium reacted with hydrochloric acid, magnesium chloride. Magnesium reacted with hydrochloric acid, magnesium chloride and hydrogen. Clear? Also aluminium reacted with hydrochloric acid, aluminium chloride and hydrogen. Aluminium reacted with hydrochloric acid, aluminium chloride and hydrogen. Similarly you can say sodium reacted with nitric acid, sodium nitrate. Okay, calcium reacted with nitric acid, calcium nitrate. Also here sulfuric acid, calcium reacted with sulfuric acid, calcium sulfate. Magnesium reacted with sulfuric acid, magnesium sulfate. So you can name this salt accordingly. Also I told you how to balance equation. I already uploaded the video, you can check that video, how to balance chemical equation. Okay, so balancing chemical equation also very important things. Okay, so check it, how to balance chemical equation. Clear? So here we discuss generally metals reacted with the acid form salt and hydrogen gas. But you have to remember here, when metal reacted with nitric acid, here no hydrogen gas is formed. Okay, here metal reacted with nitric acid, it produced salt but no hydrogen gas, because here nitric acid is a strong oxidizing agent. Okay, strong oxidizing agent. So hydrogen gas produced, there will be hydrogen gas. This hydrogen gas immediately oxidized to water. That's why we cannot see there is hydrogen gas. We cannot observe hydrogen gas. Clear? So remember, metal reacted with nitric acid, hydrogen gas is not formed, hydrogen gas is not observed, because hydrogen gas immediately oxidized to water, because nitric acid is a strong oxidizing agent. Also there is one exception case, magnesium and zinc. Magnesium and zinc react with dilute nitric acid and forms hydrogen gas. Okay, except this is happening, but except magnesium and zinc react with dilute nitric acid, it produce salt. Okay, here magnesium reacted with nitric acid, magnesium nitrate, there will be hydrogen gas. Zinc reacted with nitric acid, there will be zinc nitrate and hydrogen gas. Okay, So here no hydrogen gas is formed except magnesium and zinc. Okay, also you remember here copper do not react with the dilute nitric acid. So here when you compare here magnesium, aluminium, copper, magnesium, aluminium, they react with dilute hydrochloric acid. Okay, but here copper do not react with the dilute hydrochloric acid. Copper is highly unreactive. Copper is compared to other metals, copper is less reactive. That's why coppers do not react with dilute hydrochloric acid. Clear? So these are the things we are discussing this video. Rest of the part we will discuss next video. Okay, if you have any problems, any doubts, you can put your doubts or questions in comment box. Okay, so thank you for watching this video. Bye bye.